10 years ago, I wasn't on Android yet. I was doing web, and web was very jealous of what native had to access to. So they had push notifications, obviously, offline support. They had access to the hardware APIs. There was one thing that native was rather jealous about is distribution. Meaning, there are two things I think very important to distributions. A website, you don't need to install anything to have access to it, so there is no friction. How to call that? To get access to it, and it's also very easy to get just the latest up-to-date version of it. You don't need to reinstall something. It's just you refresh the page, you have the latest. And web was like, okay, we have the distribution, but we don't have the three others. And they were like, okay, we need those. And in 2016, progressive web apps, 2015, sorry, progressive web apps started. At the same time, there was a lot of momentum around behind JavaScript. The ES6 version got out, and instead of having one new version every few years, they were like, okay, now every 6 months we're going to get something new. And this is what PWA got. 1 year later, PWA APIs improved, and as you can see, native didn't have much improvement on the distribution side until Google I/O in 2016, where Google announced instant apps, which we are going to be calling AIA, on slides anyway. And the goal was to fix this friction of installing an app and only this side. So being up to date, it's still on you to wait for the user to update their API or their APK. And so what is an instant app? The use case that Google had in mind and the way they presented it was try before you buy. So it's really just a preview of what it is. And that's it. You just keep onboarding and you have a taste of what's going to happen. The way they do it is on-demand download on the spot, and the limit is 15 megabytes, which is going to be the key in how you want to implement it. And it's not a standalone app. Google never imagined it to be on its own. It's always going to be a lesser version of the whole app, of the main app. And that's why when you set the version code of Instant App, you always have to be minor to what you have released previously. So you can't just release an Instant App. You always have to have a stable app or the main app with a bigger version code on it. And lastly, because it's going to be accessed through URL, you need a fallback page to even just say download the APK to have access to it. And so 2016 is when it was announced, and it was actually released for production in 2017. But so this is what happened. iOS came like a few years later. They were like, oh, maybe we should do something, and they released app clips, which is more or less the same as Instant App. The UI is a bit different, but like the limitation is the same as well. And so today this is how it looks. You can see that Android, the distribution on Instant App is still the snail, because they released Instant App in 2017 and that's it. They never iterated over it. It just as is from day one, which is interesting. And we were preparing this talk like a month ago when 2 weeks ago someone was like, hey, there is a new commit on AOSP, and if you zoom in, they are announcing that Instant App are gonna, they got deprecated. They are gonna be removed in December 25 at the end of this year. And so instead of calling, the original title was Instant App Reborn, which got denied. We are going to talk about not the past, because it's still around at the moment, but we are not going to show how to build an Instant App. You don't, no code to get started the way you set it up. We are more going to focus on how we made it happen, because the limitation of 15 megabytes when you already have an existing app, or maybe 15 megabytes and you have, I don't know, 1,000 modules or whatever, had put constraints on us. And so Amo and Cash App did it in different ways. And so we're going to show how we did it. And maybe at the end we'll show what the missed opportunity that Instant Temp was. To Cyril.
Great. So as Benoît mentioned, Instant App was really built on this idea of try before you buy. Okay, so actually, if you look at this concept and you look at the Play Store, when you have an app that has both a main app and an Instant App, it automatically comes with a Try Now button. Okay, this Try Now button is close to the install button. So if you tap on install, it will install the main app, and if you tap on Try Now, it will install the Instant App. Okay. And this is actually automatic when you put a metadata in your Android manifest.xml. This metadata has to have the default URL name, and this is actually required. So if you don't put a metadata in your Android manifest, you won't have access to the Android Instant App feature. Okay, it's not going to be enabled. So you're not going to have the Try Now button, but you're also not going to have an Instant App. And true story, but in our use case, that was not working. Like, it was really not matching our expectation, and we'll see it by deep diving into the use case. But true story, you have to call someone at Google to put your package name in a whitelist somewhere in the code base. And I don't know for you and for Cash App, but for Ammo, it took me something like 10 people. I had to contact 10 persons that at some point found someone at Google that could add our package name. So just change one line of code in their code base and make sure that this Try Now button is not displayed on the Play Store. So let's dive deeper together into our respective use cases to better understand how and where AIA can shine when executed super well. So as at Ammo, what we're building social products. Okay, we have many apps actually, and what we will be focusing on today is Bump. So Bump is an app that is a location sharing app designed so that you can you can add your friends, and it helps friends to stay connected and meet up it easily. Okay, so this is the page of the Play Store, so where you can download the main app. But when you download the main app, you need to authenticate yourself, you need to fill in a bunch of information. And what we're going to focus on is not this main app use case, but the Instant App use case. And to better understand that, I will split the screen in two parts because you need to focus on two sides of the story. The first side is the sender part, so someone who has Bump installed, and the receiver side, which is basically someone that has not Bump installed on his device. So let's see what it looks like. So on the sender side, so let's say it's Benoît, actually who wants to send me his location. So what's going to happen is that he's going to navigate into Bump, look for the Add Friend button, and in the Add Friend button, it will open a panel where you can find all of your friends. And it will actually just share a link to myself. As you can see here, this is using WhatsApp. And when I send this link, automatically there is a preview display. So this is not part of the Instant App thing, but we are leveraging Open Graph so that we can display a preview of what's actually going to be provided by this Instant App. So you can see that this link is not just a link, it's actually Benoît sending me his location, because you have this context of a map and the face of Benoît. So it's super personalized. So this is really what the sender side look like. Just for privacy reasons, this link is only valid for 1 day. Okay, so if you tap on it after 1 day, it's actually going to be no up. And the second thing is, if you tap on it, you have access to Benoît's live location just for 2 hours. Once again, for privacy reasons. And on the receiver side, what's going to happen? So I'm on a device with no Bump installed. So I will get the notification from Benoît here in WhatsApp. I can tap on it, it will open WhatsApp. And in WhatsApp, what I get is exactly the same preview that Benoît saw when sending this link. What I'm going to do, because I know it's Benoît and sharing his location, I will just tap on the link. Here, what is displayed is a page or a screen that asks you to whether pick the instant experience or open the web application. And you can see at the top and at the bottom that the decoration are, overlaying the status bar, showing you that nothing was updated. And if I tap on Open App, then it automatically download, install, and start the app automatically. And this is a native app, actually. You can see that I can zoom in, zoom out, like look at the live location from Benoît, even send some emojis like that. So it really gives you a sense of progressive onboarding of the experience. And if I tap on Get at the bottom, it will open a dialog where I can install directly the main application. And so basically transfer or upgrade the instant app to a main app. And here it downloads everything, it installs the app, the main app, and it starts it, okay? So the experience is really smooth. The only difference is that in the instant app, you're in an unauthenticated mode, so we don't know who you are, obviously, because you're just someone who tapped on a link. Once you log in, we know who you are, and so we can provide more valuable information for you. So the ammo use case was very focused on three main things. The first thing was having a as smooth as possible progressive onboarding experience. The second part was really to have something super personalized. So using instant app plus, in addition with a preview, having the preview of the URLs was super helpful for us. And third, it was really context-based. Like it means nothing to get a link, a random link, because what you need is someone, a friend in front of you. So you can't try now. You can't install an instant app because you need to pick a friend. And this is actually part of the URL that is sent by your friend. So that was really why the try now experience was not working for us. When we built this app, we actually were faced with multiple challenges because there are a bunch of constraints for the instant app that we will see at the end of this talk. But basically, we were at Ammo faced with three main constraints. The first one being that the main app and the instant apps are two different apps, okay? But they are displaying very similar content, and so you want to be able to reuse code that is for the main app in the instant app. And this is actually something that was very easy for us because, as I said at the beginning, we're not just building one app. We're building multiple apps, multiple social products, and all of the code base is structured in a way that we can already reuse components. And if you look at so we have a monorepo where you can find our Android source code, and the Android directory is split between three different categories, like the apps that are containing all of the apps, the components that are basically the features of what could be the apps, and then foundation and platform. So foundation is mostly containing standard libraries that we want to enhance, and platform or our internal SDKs to do things like, analytics, navigation, stuff like that. And once you have that, it's super easy because we already had this. It was super easy to build something that was just aggregating an app that was just aggregating a bunch of components by just adding one line in our app build.gradle.kts file. In this case, I'm just adding an implementation on project.components.settings.bindings, which will add everything that settings requires. So the code, the entry points, the screens, and the assets and the resources. And sometimes, obviously, it's not enough because you want to inject some stuff that are very specific to this feature. So for instance, in the case of settings, you need to provide some settings configuration to define what the open the social networks means for this app. And this is basically the only code that you need to write, okay? And as you probably know, when using DI like this, everything is compiled time. So once you have that, it's super easy to do stuff that are very modular. So you can have, for instance, here, the avatar bindings or feature only in location, but you can also have it in location instant. Or you can even have it for the internal version of the app, like what we name it internally the happy version or the love version. And just by having a configuration that is happy implementation, I will automatically have this super secret new feature just available in this build. So this was really something that was super helpful for us, but it required one thing, which was to build an app that was made of a build.gradle.kts that was an aggregation of a bunch of components, and sometimes we had to write a bunch of stubs, like stubs dependencies. So this is really what, like, as simple as it. And if you look at the location instant source code, it's really just like taking components and aggregating components into one app. The second challenge that we had at Ammo was based on the way we do multi-platform at Ammo. So we have I would say some people might say that it's pretty exotic or unorthodox, but what we do at Ammo is, I would say, original. So we don't do KMP. What we have is that we use Rust, the Rust programming language, as the cross-platform language for both the backend, but also for the client. And all of the UI is done in Kotlin for Android and in Swift for iOS. So if we deep dive into what it looks like, so we have this Rust library that we call the core, that is made in Rust, that uses SQLite internally, but everything is built in Rust. And it exposes like RX Swift streams on iOS and flows and suspend function for Android to the Android code and the iOS code. So if you look at what's actually the iOS app, it's both the core and the iOS source code, okay? Similarly for Android, it's the core and the same core, actually, it's just built for an Android architecture versus an iOS architecture, but it's the same code. And it bundles both the core and the Android source code and resources. So this has many advantages. The first one is that the core for us is kind of a local backend. We, as a UI developer, I don't have to think about, am I doing a remote call? Do I need to cache something? Or do I need to do a call locally and then remotely and do some reconciliation of all of that? I don't need to deal with that. This is done automatically by this Rust library. The second thing is that this Rust library deals with persistence and networking. So as a UI developer, I just collect a flow, or I just subscribe to a RX Swift stream, and that's it. I have real time, I have plain old Swift or Kotlin objects to deal with, nothing to deal with, no deserialization, no caching, nothing like that. And what it does internally is it gets and sends proto via gRPC so that we are full real time. And it exposes everything to the UI through Kotlin and Swift. It exposes API to Kotlin and Swift through foreign function interface. I don't know if you're familiar with Unify, but this is what we use internally, Mozilla Unify, which is a framework to ease all of that. So that's super helpful, and really this is what makes us so fast, and we can release new features very rapidly thanks to that. The problem is it was designed originally to be used in a main app, like in an app that contains everything. And so if you look at the main app and you look at this SO file, it's actually, so the binary file of the native code, it's actually pretty heavy. It's like 18 megabytes, more than 18 megabytes. And so we had to do some choices when we started to work on Instant App, and we decided to really simplify everything and not use the REST library as a persistence and networking library, because the thing is, if you're in Instant App, you are actually not really persisting anything. Like, most of the experience you're going to do is super ephemeral. And so what it's doing is just getting a byte array from the UI that is just the response from a call that we do from the UI, and it maps that to the Unify or the FFI object that we already have everywhere in the code base. So it just simplifies all of that, just mapping proto models to the FFI models that we have in app. And so by doing so, we actually reduce the SO file by a lot, because now it's not 18 megabytes, it's just 300 kilobytes, okay? Which makes it completely possible to create an Instant App. And the third challenge that we had to do was to deal with the packaging of an Instant App. An instant app is a bit special. It has to have a version code that is lower than the main app. And so what we did is, because we have we already had like a built logic configuration, we reuse that just by using what you're used to, like having this Android DSL, the dependency DSL. We have even something that is specific to AMO, which is defining the domain for this app, as well as the deep link scheme for this app. And what we did is just creating a special plugin to initialize or to deal with the configuration of an instant app. The thing is, if you look at the source code of this plugin, it's super simple. It's actually very similar to the main app or regular apps plugin. The only thing that it does, it calls configure application, which is exactly what the main plugin does, by setting an is instant app to true. Okay, so that's the only difference. And if you look at what it is used for at the build logic level and convention level, it is just used to, one, set up Sentry. We'll talk about that later in the talk. And secondly, set up the configuration, the application version. So let's look at this application version. Like, it was very simple. We use this Boolean to get to know if we need to version it with 0 or 1, 1 being higher, so the main app, and 0 being the instant app, and that's it. And once you have that, you can tweak your version code and your version name based on this, and that's it. So if we look at what we do, it's super easy. If we look at the version code and it ends with a 0, that's an instant app. If it's a version code and it ends with a 1, it's the main app. And for the version name, it's very similar. The only thing is that we add a dash instant to the version name so that we know it's the instant app and not the main app.
Okay, for Cash App, the Cash App is trying to be a bank. You can send money, receive it. You have a physical card with a debit card to do groceries or whatever. You can trade stocks, but we wanted to try an experiment where the use case would be you enter a coffee shop, there is a QR code that takes you to a menu, you go through the flow, you place an order, and we would incentivize you to install Cash App at the end to get, in some ways. And so it's a unique use case for Cash App that is not related to its main features. This is how the experience would be. You would scan the QR code, the instant app would kick in. We skipped the transitionary screen saying, do you want to open the app or not? Because this only happens the first time. Once you go through it, you're good. And then we would show a menu. I'm not going through the end of the order flow, but you would be able to place an order. If it's the instant app, it would ask you to use Google Pay to actually place the order. Otherwise, we would use Cash App functionalities. And in our case, this is not person-based like Amo did, but we are location-based. We need a shop to actually place an order. So that's why, again, for us, the try now button didn't make sense, especially when we have already a huge app in place with regular customers. So we had as well to find a human at Google to add us to the list. And it's very niche. This is not something that we released countrywide, so we are only in the US. It was really just like 20 merchants in some remote city, not remote city, but like one city. This is not something we wanted to embed in our main app, but still wanted to get the customers to go through Cash App. And why did we use an instant app? The most easy reason is that we didn't have a web team, so no web app. And as well, we wanted to skip onboarding. Being a bank app, onboarding is a bit heavy. We need to check your ID. We would ask if you want to link a real bank account, these kind of things. We want to skip all of that. And the way we did it, because we don't want to have this niche code into the main app, is using dynamic features. When Google came out with the instant apps, you remember, so the limit is 15 megabytes, and this one's like 8 years ago. There was no 5G, there was no 4G, even 15 megabytes was like a big chunk of things to download. And when you want app to open as fast as possible, you don't want 15 megabytes, you want bytes of it. And this is what dynamic features was to address at the time. So like instant app, the, the feature is on demand download of modules of your app. This means at runtime, you're going to say, I need this module, download it, and it's going to do just that in the background. And this is why Google as well started to ask Android app bundles to be uploaded to the Play Store and not APK anymore. In your app, this is as simple as need to be to download your module. You have a name for it, and using the split install manager, you're like, give me this feature, you will install it, and using listeners, so you're basically getting callbacks of, has the download started, is it finished, has it been successful? All this info is coming back to you, and you can then just navigate to the screen that you need to navigate to. And in Cache App, we just cache this installation, and so if we have it, we just navigate to it right away, otherwise we would just install it like this. There are some reasons why you would not want to use dynamic features. Obviously, you need to download the module, so if you're offline heavy, I guess you would not want it. It requires Google Play services, so if you're in a country when it's not available, that's too bad. Likewise, your app has to be distributed through the Play Store, so you can't go through alternative solutions. Testing could be, it's not really difficult to test, but because the download happens at runtime, you could have problems. We had one when we bumped AGP, compilation is fine, but R8 was actually now stripping the dynamic features for us, and at runtime it would just crash saying, we don't have this feature. That was too bad. And there are other bugs related to it, and that's why in-house we open source a really small Gradle plugin, better dynamic features, which goal is to address a few bugs. And so you would apply this plugin on your in your app. We would do things like guaranteeing dependency versions. So we would create a Gradle log files to make sure that everything is strictly pulled in. There is one bug around manifest file merging. Again, this plugin will take care of it for you. And we have other things. And so we have this small library that we use inside. And how it looks is we have the main app, in which we don't want to put the instant app, which we call local, because, as I said, it's only like 20 merchants in the US, and we have like millions of customers. There is no point in adding all this code in the main APK. And main used to be just a regular app, but we made it a dynamic feature just by turning it on its head. And so the entry point, the dynamic feature is the whole app. But we added one, and so the main app is going to be dependent on the local dynamic feature. If someone has onboarded into our experiment, they would be able to navigate to those local screens using dynamic feature to download it locally. But so we need a root, which we call CacheOS, and both main and local depends on it. And CacheOS will be the root of everything. So if main and local share things, like the data model for types that we send over the network, for instance, that would be in here. When we release the instant app, we only take local and CacheOS. It will be a bit like the core that Bump had. But if we release the main app, it's going to be everything. But the three of them are dynamic features. It's just that the relationship between them can be pulled in at runtime. But so obviously for main, it happens on install. We don't have to download it. And this is how we did it. We gave it a try to have multiple settings files. So if we wanted to only code for the instant app, anyway, we tried to do something a bit like what Dropbox released with Focus, which is not really working anymore. It has lots of downsides, basically trying to make sure that the main app settings and the instant app settings are both working at all times. There is a lot of context switching, and it was painful to do.
Yeah, so as Benoît mentioned, one of the very important limitation of the Instant App is its download size. So what I explained at the beginning for the ammo use case is we ended up having an Instant App, so being below the main limitation fairly easily. But what is this limitation? So first, if you're in a local environment, it's actually infinite. Like you can do whatever the size of the Instant App, it's going to work. But when you go on production, regardless of the track, it's around 15 megabytes. And 15 megabytes is for your current CPU architecture and your current density. So you need to take the maximum of all of the possible combination of your targets. Actually, it's a bit more complicated than that, but who cares now that Instant App is not a thing anymore? Yeah, not yet. The thing is, regardless of the limitation, like being below 15 megabytes for us was fairly easy. We were around 8, but the smaller the better. And it's not specific to Android Instant App. Like we're all struggling to try to reduce the size of our app size or apps as much as possible. Because if you have something that is just a few kilobytes, it's going to be downloaded much faster than if it's 10 megabytes. And this will improve the user experience by a lot. So all of the things that you need to think about is how to slim down the binary as much as possible. This could be actually a talk, a 1 hour talk. There is a bunch of ways to do it. Like I added some stuff that you could do. But to me, what's important is really to have a mindset where you measure everything. Back then, when Android Instant App was released, there was no tool. Now we have a tool that is called APK Analyzer that is available in Android Studio, and it's really your best friend for that. Because it changes absolutely everything. You can analyze the APK by just drag and dropping the APK on the Android Studio icon, and it gives you the native size of your library, from the size of your native libraries, the assets, the size of your DEX file, your resources or structured tables of your resources. This is super helpful. So this is, for instance, here you can see that this is the APK analyzer on one of the latest version of our Instant App, Bump Instant App. And if you look at it, the download size is 4 megabytes. But what I'm measuring here is an APK, not an AAB or what actually provided or sent to the user in the end. So you need to remove also like the densities because you have multiple densities in this APK. In practice, we don't measure really what's the, at Ammo, we don't measure like the minimal or the maximum size over the possible configuration of our device, targeted devices. What we used is this, because if you reduce that, basically you reduce the size for all densities and all CPU architecture. So this is what we've done by really leveraging this tool. And as you can see the DEX file. You can see, so for instance, you can see here in the DEX file that Sentry is actually the biggest offender in terms of size in the DEX file. So we wanted to be able to observe the Instant App, but it takes 300 kilobytes just for Sentry, which is more than the feature itself. And if you look at the binary here, it's, as we said before, 300 kilobytes, a few hundred kilobytes. So APK Analyzer is not digging into the native code, but there are other tools for that. I don't know if you're familiar with Google Bloaty, which is a utility to analyze binary executables, which is super helpful, even though it's not super well supporting Rust in particular, because Rust is mangled in a way that Bloaty is not super familiar with it. But in general, optimizing app size is really an art of thinking and balance, because if you really if you want to reduce the app size, most of the time you're going to remove some features. It's never for free. Okay, so it's really a balance. So like I wanted to give you 3 examples that we've done at Ammo to reduce an app size that was 8 megabytes at the beginning to be about 4 megabytes. The first thing we did was to look at our own dependencies or external dependencies. Sorry. So we were using, for instance, MLKit entity extraction. I don't know if you're familiar with it, but it's a Google library that helps you parse a text and look for dates, addresses, links, stuff like that. And it will give you the span in your text where you have the link, and it will say, hey, for this span of text, you have actually a link. So on paper, it's super nice. It's really nice. But the thing is, it comes with 2 megabytes, a native lib of 2 megabytes. Which is nice, but for an Instant App, it's probably not worth the size. And so what we did is we wrapped it into our own interface that we use everywhere in the code base. And for the instant app, we use the system entity extraction mechanism, which is part of the Android APIs. And for the main app, we switched to MLKit entity extraction. And that gave us about 2 megabytes of gain. The second thing that we did, like we saw about it, was to focus on Sentry. So Sentry by default, in our case, because we're using native code and Dex code or Java code, we were using Sentry as a crash reporter for both the Java side or Kotlin side and the native code. But the thing is, as I showed at the very beginning, we reduced the amount of Rust code by a lot. Like it was only 300 kilobytes, and so the API surface was almost like inexistent. It was just mapping proto models to some Unify models. And so we decided to get rid of the NDK to get rid of at least 1 megabyte. It was 1 megabyte that we removed just for that. We kept the Java or Kotlin and SDK, but still, like it's also something that you can discuss because it's 300 kilobytes just to have your instant app observable in production. And the third thing that we did was actually to look at our own dependencies. So as I said at the beginning, building an instant app for us was just adding some components. But those components was initially built for a main app. Like when you send these emojis, if you remember the video, you send these emojis. This is exactly the same animation that you have in the main app, but these modules actually contains the receiver part as well as the sender part. But when you are in an instant app, you only actually are a sender. You can't receive anything because you're not authenticated. So what we had to do was very simple, and it helped us reduce by 2 extra megabytes. So we decided to split some modules in 2 parts. One part which was the sender part, and one part which was the receiver part. And so the instant app was only depending on the sender part, while the main app was depending on both the sender and the receiver parts. So really look at your own code. Like you can obviously look at your external dependencies, but your own code is also super important.
As I said earlier, the instant app were released in 2017, and there was no iteration on it. So sample were old, and it was a bit of a pain to work with it. And so we want to look back to have a kind of a debriefing on it. So first, the UX for the customer, really bad. As you saw, the Android Nougat using, action bar Sherlock, asking if the customer wants to use the instant app or web is just super ugly. You can't design it, nothing. This is really sad. As a developer, the experience is also really bad. For instance, because there is the try now button and the fallback to web, you need to set a default URL to your instant app. But if you forget to do so, you will not have any error. You'll be able to upload your instant app, and you'll wait hours wondering why you can't use it. That's one of the reasons, and it's one of many. And lastly, the lack of configuration, especially around the try now button not being, configurable. You can't design the transition screens, and that was too bad because we used it recently and we thought that would be nice. Talking of, iOS app clips, they have a bit more momentum to it. They created really a welcoming experience. This is the middle and the right are the equivalent for bump and cache app, or what the app clip look before opening the app clip, so the instant app. They can design it, they know what it's going to be. It's way more trustworthy, way more welcoming, way more, better for everybody. And on the left is, for instance, some integration that iOS did in iMessage. If they detect an app clip URL, they would just expand it as a preview, including the button to just open it. The biggest irony to us is that Google is getting rid of Instant App, but for the iOS apps, so Google Maps, for instance, they rely on app clips to get discovered by the iOS customers, since like Google Maps, for instance, is not installed by default on iOS. Maybe it's not a different team or the people behind Instant App just left the company or got the promotion and were happy. We don't know, but we believe it's a missed opportunity, and farewell Instant Apps. Thank you.